Hey guys, so in this video, we are going to talk about interpolation using a single polynomial. Interpolation is a procedure in which a mathematical formula is used to represent a given set of data points such that the formula gives the exact value at all the data points and an estimated value between the points. So yung difference nito doon sa curve fitting natin is sa curve fitting, yung mathematical formula na fino-formulate natin doon is just a best fit. Hindi talaga exact. So dito sa interpolation, we need our mathematical formula to give us the exact value at all the data points. Now in this video, we will do this using a single polynomial, regardless of the number of points. So as we have mentioned in our previous video, if we are given a set of n data points, then we can actually formulate a polynomial of degree n-1 that will pass through all of the given data points. For example, if we have 2 points, then the polynomial of first order will pass through all of our points. So a straight line lang connecting the 2 points, like in this example here. So makikita natin dito na yung mathematical formula that represents this line is a polynomial of the first degree. So linear lang siya. Again, for n data points, a polynomial of the n-1th degree will pass through all of the given points. Ngayon naman, for example, we have 3 points, then a polynomial of second degree will pass through all of the points. So in this case, ito yung mathematical formula niya. So that is second degree. Again, yung main purpose natin in formulating these polynomials is so that we can use them in order to estimate values between the given data points. So for example, here, kailangan nating makuha yung value ng function natin at x sub 1. Okay, so using the formulated polynomial, isa-substitute lang natin yung value ng x sub 1. And then, our interpolating polynomial will give the estimated value of the function at this point. Now take note that for n data points, there is one and only one polynomial of order n-1 that passes through all the points. So for example, there is only one straight line that connects 2 points. So similarly, only one parabola connects a set of 3 points. So polynomial interpolation consists of determining the unique n-1th order polynomial that fits n data points. However, this polynomial can be written in different forms. Okay? So, although unique yung polynomial natin, iba-iba yung form niya. So, in this video, we are going to derive and discuss 3 of these forms. So, first is yung standard form, second is yung Lagrange, and then third is yung Newton's form ng polynomial natin. Okay. So first, let us talk about the standard form polynomial. Now, the general formula for an n-1th order polynomial can be written as f of x equal to a sub 0 plus a sub 1x plus a sub 2x squared plus ... So hanggang a sub n-1 times x raised to n-1. Okay, so this formula is for n data points. Again, yung order natin dito is n-1. Now, yung kailangan lang natin gawin dito is we need to determine the values of these coefficients. So, a sub 0, a sub 1, hanggang a sub n-1. Now, a straightforward way for computing the coefficients of this polynomial is based on the fact that n data points are required to determine the n coefficients. So, as we will show in the following example, this allows us to generate n linear algebraic equations that we can solve simultaneously for the values of our coefficients. So, let's take a look at this example. Determine the coefficients of the parabola f of x equal to a sub 0 plus a sub 1x plus a sub 2x squared that passes through the following points. Okay, so meron tayong mga given points dito. Again, we need to formulate a parabola that will pass through all of these points. So since we have 3 data points, we need to formulate a polynomial of second order. So that is a parabola. So in order to generate this polynomial in standard form, bali yung gagawin lang natin is we will simply substitute these points to our polynomial. So again, yung polynomial natin is of this form. So using our first point, bali ilalagay natin yung value ng x equal to 300. And then yung value naman ng y equal to 0.616. And then we will do this for the two other points. So for the second one, yung x natin 400 and then yung y 0.525. And then for the third equation, we have 500 for the value of x and then 0.457 for the value of y. So now we have a system of 3 equations and then 3 unknowns. So, yung gagawin lang natin dito is we are going to solve this system of linear equations using the methods that we have discussed in our previous videos. And now, we will obtain the value of our 3 coefficients. So, for our first coefficient, a sub 0, that will be equal to 1.027. And then for our second coefficient, a sub 1, that will be equal to negative 1.715 times 10 raised to negative 3. And then for our third coefficient, a sub 2, that will be equal to 1.15 times 10 raised to negative 6. Therefore, yung polynomial natin that will pass through all of the given data points will be y equal to 1.027 minus 1.715 times 10 raised to negative 3x plus 1.15 times 10 raised to negative 6x squared. Okay? So, pwede nyong i-check yung na-formulate nyo na polynomial by using the given data points. So, isa-substitute nyo lang yung value ng x dito and then i-check nyo kung same yung value ng y na makukuha nyo. And then, you can also use this polynomial in order to interpolate or estimate the value between the given data points. Okay. However, in practice, solving the system of equations, especially for higher order polynomials, is not efficient. So, mas mataas yung order ng polynomial natin or kung mas marami yung data points natin, mas marami din yung kailangan nating isolve na system of linear equations. But don't worry, no? Because it is possible to write the polynomial in other forms, again, as we have mentioned earlier. So, these forms are usually much easier to formulate, especially for higher order polynomials. So, next, we are going to talk about Lagrange interpolating polynomials. Now, Lagrange interpolating polynomials are a particular form of polynomials that can be written to fit a given set of data points by using the values at the points. So, yung kagandahan sa form na to is that this form can be written right away and do not require any preliminary calculations for determining coefficients. So, hindi na natin kailangang isolve yung mga coefficients natin. Okay, so let's start by taking a look at 2 data points. So for 2 points, the first order Lagrange polynomial that passes through the points has this form. Now if we substitute the 2 points, x sub 1, y sub 1, and x sub 2, y sub 2 into our polynomial here, we can actually obtain the value of our coefficients. So, ito na ngayon yung value ng coefficients natin. And now, if we substitute back the coefficients a sub 1 and a sub 2 into our first order Lagrange polynomial, we will now have a polynomial of this form. Okay? So, this equation is referred to as the linear Lagrange interpolating polynomial. So, this equation is actually linear. Okay? Now, it is easy to see that if we substitute x sub 1 into x here, then the value of the polynomial will be y sub 1. And then if we substitute x equal to x sub 2, then the value of the polynomial is y sub 2. Now, if we are going to apply this polynomial to a set of 2 data points, so ilalagay lang natin yung value ng points natin dito. So, there is no need to calculate for the values of any coefficients. Okay, so next naman, let's take a look at 3 data points. So, the second order Lagrange polynomial that will pass through these points has this form. Okay, now we will derive the value of our coefficients here using the same method that we have used earlier. So if we try to substitute the first point here, we will actually obtain the value of our first coefficient a sub 1. Kasi yung second and third terms natin, magiging 0 lang yung value nila. And then, if we substitute our second point, x sub 2, y sub 2, then makukuha naman natin yung value ng second coefficient a sub 2. And then, same din pagdating sa third point natin, so makukuha naman natin yung third coefficient. Now, once the coefficients are determined such that the polynomial passes through the 3 points, the polynomial will now have this form. So, kung mapapansin nyo, wala na tayong coefficients dito. Okay? So, this equation is a quadratic function of x. Now, if we compare this to our linear Lagrange interpolating polynomial, we can see some similarities. So, for our first term, nandagdagan lang siya ng x minus x sub 3 over x sub 1 minus x sub 3. And then, similarly, sa second term din natin, nadagdagan siya ng x minus x sub 3 over x sub 2 minus x sub 3. And then, meron tayong third term dito. Now, both the first and second order versions as well as higher order Lagrange polynomials can actually be represented concisely by this function. So, we have f of x equal to the summation of y sub I times L sub I of x from I equal to 1 up to n. Now, our L sub I of x is actually equal to this product function. Now, this product function is actually called the Lagrange function. So, medyo similar lang siya doon sa summation na notation natin. Pero in this case, instead of adding our terms, imumultiply natin sila. Okay? So, for example, we have 2 data points. So, yung value ng n natin dito will be equal to 2. So, our polynomial given by this function will be equal to the summation of y sub I. So, first term natin dito, yung value ng I natin will be equal to 1. Kasi yung I natin, again, that is from 1 to n. So, for our first term, yung I natin is equal to 1. And then, we will multiply this by our Lagrange function. So, take note na sa Lagrange function natin, yung value ng j natin is same pa rin. So, from 1 up to n. But j should not be equal to I. Okay, so in this case, sa first term natin, we cannot actually substitute a value of j equal to 1. Kasi yung value ng I natin sa first term is equal to 1. So instead, we will simply substitute the value of 2 for our j. Okay, so this will be x minus x sub j. So that will be x sub 2 over x sub I. So again, for our first term, I is equal to 1. And then minus x sub j. So that will be x sub 2. And then for our second term, same lang yung gagawin natin. But in this case, yung I natin will be equal to 2. And then pagdating naman sa Lagrange function natin, we cannot substitute a value of 2 for our j. Kasi again, j should not be equal to I. Okay, so this form is actually similar doon sa na-derive natin kanina. Now, moving on to 3 data points, bali yung n natin will be equal to 3. So, we will have 3 terms. So, for our first term, yung value ng I natin will be equal to 1. Okay, so we will have y sub 1. And then, we will multiply this by our Lagrange functions. But take note, again, na yung j natin should not be equal to I. So first, we will have x minus x sub 2. So j natin dito is equal to 2 over x sub 1 minus x sub 2. And then, we will multiply this by x minus x sub 3 over x sub 1 minus x sub 3. Okay? So again, product notation. So instead of adding them, we will multiply the Lagrange functions. So for our second term, yung value naman ng I natin will be equal to 2. So we will have y sub 2 multiplied by our Lagrange functions, where j is not equal to 2. And then lastly, for our third term, we will have I equal to 3. So we will have y sub 3 and then multiply lang natin yung Lagrange functions natin, but yung j natin will not be equal to 3. So, 1 and 2 lang yung value ng j natin dito. Okay. So, ngayon, kung mapapansin nyo, this is actually similar doon sa Lagrange function na na-derive natin kanina for 3 data points. Okay? So, itong function lang na to, yung tatandaan nyo, if you are going to use the Lagrange form of our interpolating polynomials for n data points. Okay. So, let's apply this concept in this example here. So, sabi dito, use a Lagrange interpolating polynomial of the second order to evaluate the density of unused motor oil at temperature T equal to 15 degrees Celsius based on the following data. So, kung mapapansin nyo, yung sa data natin, wala tayong value for T equal to 15 degrees. So, first, we need to formulate an interpolating polynomial of the Lagrange form. So, since we have 3 data points, yung n natin dito will be equal to 3. Therefore, our Lagrange interpolating polynomial will have this form. Okay? So, yung gagawin na lang natin dito is we will substitute the given data points into this function. So, for our first point, x sub 1, y sub 1, ilalagay natin dito. And then, same then for our second point, x sub 2, y sub 2, and then, third point, x sub 3, y sub 3. So, diretso na. Wala na tayong isa-solve. Bali, isa-substitute lang natin yung mga given points. So, after substituting the given points, yung polynomial natin ngayon will look like this. So, we can actually simplify this further. Okay? So, now we have this equation. And actually, pwede pa natin itong i-simplify pa, no? Evaluate natin yung numerator natin, and then we will combine like terms. So, nasa sa inyo na yon. But then again, this form is already acceptable. Now, in order to solve the problem, kailangan daw natin hanapin yung density at temperature equal to 15 degrees. So, using the Lagrange interpolating polynomial that we have formulated above, ilalagay lang natin yung value ng x equal to 15. So, pwede nyo nang diretso i-calculate or i-substitute yung value ng x dito. So, yung value ng function natin at x equal to 15 will be equal to 1.3316875. Okay, so that's it. Madali lang yung Lagrange function kasi wala na tayong iso-solve. Yung gagawin lang natin is we will simply substitute the given data points. Now, if you try to solve this problem, but instead of using a Lagrange interpolating polynomial, yung gagamitin nyo is yung standard form. So, f of x equal to a sub 0 plus a sub 1x plus a sub 2x squared, you will actually obtain the same value for x equal to 15. Kasi again, sabi natin kanina, the polynomial that will pass through all the given data points is actually unique. Okay? So, iisa lang sila. Bali, yung pinagkaiba lang nila is the form in which they are written. Okay? So, next, we are going to talk about the Newton's form of our interpolating polynomials. Now, Newton's interpolating polynomials are a popular means of exactly fitting a given set of data points. So, the general form of an n-1th order Newton's polynomial that passes through n points is given by this function. So, the special feature of this form of the polynomial is that the coefficients a sub 1 through a sub n can be determined using a simple mathematical procedure. So, hindi na natin kailangang mag-solve ng systems of linear equations katulad doon sa standard form in order to obtain the value of our coefficients. So, ito yung kagandahan sa Newton's form. Now, once the coefficients are known, the polynomial can be used for calculating an interpolated value at any x. So, same doon sa ginawa natin kanina, let us first take a look at the Newton's polynomial for two given points. Okay, so n natin dito will be equal to 2. So, from our general form, yung nasa taas, the first order Newton's polynomial will have this form. F of x equal to a sub 1 plus a sub 2 times x minus x sub 1. So, again, we are given 2 points. So we need to obtain the value of 2 coefficients. Now these coefficients can be calculated by considering the similar triangles shown in our figure. So we have the smaller triangle CDE and then yung larger triangle natin CAB. Okay? So hopefully nakita nyo yan. Again, by similar triangles, we will have DE over CE equal to AB over CB. So in terms of our given points, that will be equal to f of x minus y sub 1 over x minus x sub 1 equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now solving for the value of f of x from this relationship, we will have this equation. Now if we compare this to our first order Newton polynomial doon sa taas, we can see na yung value ng first coefficient a sub 1 natin will be equal to y sub 1. And then yung value naman ng second coefficient a sub 2 natin will be equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay? So ngayon, ito yung magiging value ng coefficients natin. So next, let us take a look at the Newton's polynomial for 3 given points. So 3 points tayo dito. So this will be a parabola. Now the second order Newton's polynomial will have this form. So same pa rin, the coefficients can be calculated by substituting the 3 points to this equation. So if we substitute our first point here, bale x natin is equal to x sub 1 and then yung f of x naman natin will be equal to y sub 1. So our second and third term here will actually be equal to 0 kasi magiging x sub 1 minus x sub 1 siya. Okay, so now we are left with y sub 1 equal to our first coefficient. So same din kanina dun sa nakuha natin for our first order Newton's polynomial. And now, if we substitute our second point, so x sub 2, y sub 2 naman, and then yung value ng a sub 1 natin, which is equal to y sub 1, we can actually obtain the value of our second coefficient a sub 2. So that will be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Again, kung mapapansin nyo, same lang to dun sa nakuha natin kanina for our first order Newton's polynomial. And now, if we substitute our third point, x sub 3, y sub 3, and then yung dalawang coefficients natin na na-solve kanina, a sub 1 and then a sub 2, so makukuha natin yung value ng third coefficient, a sub 3. So that will be equal to this equation. Now actually, merong pattern yung values ng mga coefficients natin dito. Okay? So maybe hindi nyo pa masyadong makita. So let's take a look at 4 given points naman. Now for 4 given points, the third order Newton's polynomial will have this form. So we have 4 unknown coefficients here. But then again, these coefficients can easily be calculated by substituting the 4 given points. Now the resulting values for the coefficients a sub 1, a sub 2, and a sub 3 will actually be equal or the same as for our second order polynomial. So same lang kanina. Now the formula for the coefficient a sub 4 can be obtained by substituting our fourth point, x sub 4, y sub 4, into our equation, as well as the values of the 3 other coefficients. So now, the value of our fourth coefficient will be equal to this equation. So again, a careful examination of the equations for our coefficients shows that the expressions follow a certain pattern. Now this pattern can be clarified by using the concept of divided differences. So balikan natin ulit yung 2 points natin. So for 2 points, yung tinatawag na divided difference or the first divided difference is written as f and then we have bracket x sub 2, x sub 1, which will be equal to the difference of y sub 2 minus y sub 1 divided by the difference of x sub 2 minus x sub 1. And ito actually yung value ng second coefficient a sub 2 natin. So, recall na yung value ng first coefficient a sub 1 natin, that will simply be equal to y sub 1. Now, for 3 points, the second divided difference, so second, written as f and then open bracket x sub 3, x sub 2, x sub 1 is defined as the difference between the first divided differences f x sub 3, x sub 2 minus f x sub 2, x sub 1 divided by the difference of x sub 3 minus x sub 1. Okay? So, yung first divided difference f x sub 3, x sub 2 natin, that will simply be equal to, so sa numerator, y sub 3 minus y sub 2, and then that will be divided by x sub 3 minus x sub 2. And then yung first divided difference f x sub 2, x sub 1 naman natin, so same lang yan doon sa taas, no? And then again, this will all be divided by x sub 3 minus x sub 1. Now, this second divided difference is actually the value of our third coefficient a sub 3. Meron lang pattern yung first divided difference natin, ano? So, sa numerator, you have the difference of y, and then sa denominator naman natin, you have the difference of x. Now, extending this concept for 4 points, the third divided difference, written as f x sub 4 hanggang x sub 1, is defined as the difference between the second divided differences, f x sub 4, x sub 3, x sub 2, and f x sub 3, x sub 2, x sub 1, and then divided by x sub 4 minus x sub 1. Now, if we expand this, yung second divided differences natin will be equal to this, no? So, f x sub 4, x sub 3, x sub 2 will be this one, and then f x sub 3, x sub 2, x sub 1 naman will be equal to this. And then, further expanding our first divided differences, we now have this equation for our third divided difference. So, this is actually equal to our fourth coefficient a sub 4. Okay. So, medyo complicated siya, no? Yung derivation. But in applying this to a problem, madali lang siya. Okay, so trust me guys, madali lang siya. Again, to make it easier, we are going to use the table of divided differences. So for example, for 5 data points, yung table of divided differences natin will look like this. So ito yung magiging values ng mga coefficients natin. So again, for n equal to 5 data points, we have 5 coefficients din. So, paano ba gawin itong table na to? Okay, so let's take a look at this example. Determine the third order polynomial in Newton's form that passes through the following points. Calculate the coefficients by using a divided difference table. We have 4 given data points here, so we need to formulate a third order Newton's interpolating polynomial. So, Newton's polynomial for the given points has this form. Again, para makuha natin yung values ng coefficients natin, gagamit tayo ng divided difference table. So, first na gagawin nyo when making this table is to write our given data points. So, in our first column here, ilalagay natin yung value ng x, and then sa second naman, yung value ng y. So, again, yung value ng first coefficient a sub 1 natin will be equal to y sub 1. So, yung value ng first coefficient a sub 1 natin will be equal to 52. So, next na gagawin natin is we are going to get the first divided differences. So, using these 2 data points, bali again, yung ilalagay natin sa numerator ng divided difference natin is yung difference ng y values. So, we will have 5 minus 52. And then sa denominator naman is yung difference ng x values. So, that will be 2 minus 1. Okay? So, this will be equal to negative 47. And this is actually the value of our second coefficient, a sub 2. Okay? So, for our next points, kukunin din natin yung divided differences nila. So, for our second and third points, again, sa numerator will be the difference of the y values. So, we have negative 5 minus 5. And then sa denominator, yung difference naman ng x values. So that will be 4 minus 2, and this will be equal to negative 5. And then, for our third and fourth points, same din yung gagawin natin. Next is kukunin naman natin yung second divided differences. So, yung titingnan naman natin ng mga values is yung sa first divided difference natin. So, for the numerator, we will have negative 5 minus negative 47. And then again, sa denominator, ilalagay natin yung difference ng x values natin. Yung gagawin nyo lang is iti-trace nyo lang. Okay? So, hanggang makarating kayo doon sa first column nyo. So, in this case, we will have 4 and then minus 1. Okay. So, yun yung denominator natin. And now, this will be equal to 14. So, ngayon, ito yung magiging value ng third coefficient a sub 3 natin. Okay. So, next, kukunin din natin yung second divided differences ng next 2 points. So, again, sa numerator, we will have negative 35 minus negative 5. And then, for our denominator, that is the difference of our x values. So, same pa rin yung gagawin nyo. Iti-trace nyo lang hanggang makarating kayo doon sa first column. That will be 5 minus 2. And this will be equal to negative 10. And now, in order to determine our last coefficient, we are going to solve for the third divided difference. So, using the values of our previously obtained second divided differences, so yun yung ilalagay natin sa numerator, negative 10 minus 14, and then divided by, again, the difference of our x values. So, same pa rin yung gagawin nyo, iti-trace nyo lang hanggang makarating kayo doon sa first column. So, this will be 5 minus 1. Therefore, this will be equal to negative 6. Okay? So, ito na ngayon yung value ng fourth coefficient a sub 4 natin. Now that we have determined the values of our coefficients, we'll simply substitute it back here as well as the corresponding values of x from our data points. So, x sub 1, x sub 2, and then x sub 3. So, ngayon, our Newton's interpolating polynomial will be f of x equal to 52 minus 47 times x minus 1 plus 14 times x minus 1 times x minus 2 minus 6 times x minus 1 times x minus 2 times x minus 4. Okay? So, mas madali siya kumpara doon sa standard form natin kasi hindi na natin kailangan mag-solve ng mga systems of linear equations dito. So, nasa sa inyo na yun kung anong form yung gagamitin nyo. Standard form, yung Lagrange form, or yung Newton's form for your interpolating polynomials. Okay, so that's it for this video guys. Hopefully meron kayong natutunang bago. So, see you on the next one.